Okay, we're going to now work a couple of story problems out of section 5.2. We're working with some exponential functions and equations. And as it turns out, I did this video once and my camera had a problem. So what I'm going to do, instead of redoing it again, I'm simply going to talk through it and I'll uncover it as I go. So let's first read the problem. I'm looking at problem number 33 out of section 5.2, titled Elk Population. And as it turns out, this problem and the next one are very similar to problems that you'll be assigned in the homework. So problem 33 reads like this: 100 elk, each 1 year old, are introduced into a game preserve. The number NT alive after T years is predicted to be, and then they give you an equation. Estimate the number of live after, and then they give you three times. They want you to figure out for 1 year, and then part B is 5 years, and then C is 10 years. So basically, they put some elk into the game preserve, and then they're going to figure out how many elk should be alive after a certain number of years. And of course, we know that the elk population will decrease because the elk will die, some of them. So here's the equation they give you. N sub t equals 100 times 0.9 raised to the t power. N is the number of elk, and t is the amount of time in years. And that's what I wrote here. N is the number of elk, and t is the time in years. And just out of interest, if we look at this equation for a minute, this is an exponential equation. And like we talked about in class, if you look at the base of that exponent, since it's less than 1, we have what we call a decaying function. The value is going to drop as the exponent increases, which sort of makes sense because we expect the number of elk to decrease over time, because some of them will die. So the first thing they say is, please figure out how many elk are left after 1 year. You simply plug in 1 year, you put a 1 in for t, and then do the math. And actually, for this one, I didn't even need my calculator, because when I put in t for 1, I have 0.9 to the first, which is just 0.9, and 0.9 times 100 is just 90 elk. All right, so this is not a very difficult problem. They give you the equation, and now we're simply plugging in the time for t, and then doing the math. So part B said, how about figuring out how many elk are left after 5 years? So you put in a 5 for t, which I did right here. And this time I did grab my calculator and I had to punch in 0.9 and then raise it to the 5th power. And then when I multiplied that by 100, you end up with 59, which means there are 59 elk left after 5 years. And then finally, they ask how many elk would be left after 10 years. So you simply take your equation, set t equal to 10, you grab your calculator, crunch the numbers, and you're left with 34 elk. So really not a very hard problem. The key thing is putting the number in correctly and being able to use your calculator. Now the second problem I looked at was number 43, titled Automobile Trade-in Value. Let me read it real quick. If a certain make of automobile is purchased for C dollars, its trade-in value, V of t, at the end of t years is given by, and they give me an equation. If the original cost is $25,000, calculate to the nearest dollar the value after 1 year, 4 years, 7 years. In other words, and everybody understands this, you buy a car, the original cost of the car is $25,000, and then you're going to figure out how much the car is worth after a certain amount of time. In this case, after 1 year, 4 years, and 7 years. And they actually have an equation that's going to estimate how much the car is worth. And here's the equation. In the book, they have 0.7, well, first V of t, V is the value of the car. And in the book, they write V of t equals 0.78 times C, where C is the cost. Well, they tell me the cost of the car originally was $25,000, so I went ahead and put in the $25,000 for C. And then times 0.85 raised to the t minus 1 power. So all we're going to do is when they give us the number of years, I put that in for t, and then you do the math. So for part A, they say, how much will the car be worth after 1 year? So you simply take that equation, and you can see here I put in a 1 for t, and what I showed here was that, so I have 1 minus 1, which is 0, and of course any time you have an exponent raised to a 0 power, the whole exponent just becomes 1. See, that's what I wrote here, this whole thing becomes 1. So after 1 year, the value of the car is $19,500. For part B, they said, what's the value after 4 years? Now you simply put in a 4 for t. So now your equation becomes this, where you have 4 minus 1. So you grab your calculator, and now you have 0.85 raised to the third power, and you do the calculation, and you get the car would be worth $11,975. And I guess when I read it again, they said to the nearest dollar, so I would just $11,975. And fine, they said, how much is the car worth after 7 years? So you put in a 7 for the t, and you do the math. And once again, if I get rid of this, the car will be worth $7,354. All right. So not that difficult, especially when they give you the equations you're going to use.